Welcome to the Model Vision podcast. It has been some time, but we are back with a very special episode focusing on digital engineering, a very hot topic for us specifically, but I believe a lot of our customers too. Today I have Casey, John, and John with me to talk about digital engineering and really just give an overview of what it is and then answer some of those questions that might help you decide if it's something you need for your program or if it's something that you need for another reason. So everybody, welcome. Thank you for being on. I'm going to start with John Sliger as far as introductions go. Do you want to give a little bit of information about who you are, what you do for the company, that kind of stuff?
Absolutely. John Sliger, system engineer, model-based system engineer. Can't claim digital engineer as much as John DeHart can, but definitely building up the skill set there. Currently supporting our Navy aviation customer over on the Future Vertical Lift program, now called the Vertical Takeoff and Landing Family of Systems as we continue to add more platforms there. But it's a completely digital engineering and model-based approach to DoD acquisition.
John DeHart or Casey? You can decide which one, whoever goes next.
Devontae Casey here, currently supporting and underneath John Sliger here as product owner as a part of FBL. Background includes a lot of operations, 5 years in the Marine Corps with the unmanned aircraft squadrons, training and teaching and also deploying systems as well. And down with AVIAN doing model-based systems engineering.
Awesome. Yeah, John DeHart here. I've been kind of every type of engineer over the last around 20, 25 years. Moved over into systems about 10 years ago. I'm working with John and Casey here to support NavAir, helping them put together their digital environment. And that's been, quite a task because there's not many out there in the world. So we're really, starting from scratch and we're working through it daily. It's been fun, but, stressful. So it's been, hopefully we're getting better at it.
Awesome. So let's just dive into, we keep referencing digital engineering. Obviously, that's the topic of this episode, but can you guys give a, maybe not brief, but an overview of what digital engineering actually is?
John, you want to go?
Yeah, I'll start and then you can back me up. Yeah. I think at this point, a lot of people have heard about MBSE, right? And an MBSE transformation, which in systems engineering world, it's taking all the paper-based, the paper-centric approach, document-centric approach, and moving towards a more model-based approach, right? Digitizing those products, but doing so in a way that an object-oriented manner, so that way it's exploitable by not only the model itself, but other downstream tools and products. So the downstream tools and products is where the digital engineering piece comes together. So it's great if you have this system model that describes your behaviors, the state's requirements, the structure, right? But you have that, but now you need to do something with it, right? That's just part of the design effort, right? Now you need to go through and perform testing on it, perform different analyses on it. So that comes with the use of other software tools, but in order to connect all that together, they need to interact, connect, communicate, so that way data can pass through them, and that way you can start to achieve a more automated workflow pipelines to enable reoccurring analyses. John?
Yeah, I mean, the big part for me is the automation part. So it turns out that automating your business is one of the hardest things to do in the world, and the digital engineering aspect of what we've been building these models for years. A lot of us have been developing engineering models and making miniature workflows, but not full-scale business workflows that include, mechanical engineering models, electrical engineering models, test and evaluation stuff. That just did not exist. It kind of in their own silos, and they were kind of connected. But now we're really looking to connect all that up all the way through the life cycle and then keep doing it back around, hopefully to shorten the development cycle time for new aircraft or new machines, as any machine really. But that's the goal there. But to me, the big point is the automation part. We don't discuss it much and we really need to start talking more about that.
Yeah, I think as a company, one of the biggest jobs that we have is to make our customers' lives easier. Having you guys with the technical background to automate a lot of these things that are happening on base or happening for different programs is definitely ideal in helping to make their lives easier through automation. What I guess the next part of this is just why is digital engineering becoming so popular? Like I understand the automation part. Does it tie into anything else? Is there a bigger picture here that digital engineering might play with? I mean, the hot things on the top of my head right now are like AI and machine learning. Does that tie in anywhere?
In general, it enables it. It enables the data analyses to be exploitable by machine learning, by model based analysis, by AI, right? I think the big thing. So you say AI, we're saying automated, right? It's not it's a level of automation to be able to click a button and hit go manually, and analysis is performed, right? Or a multi-step analysis is performed. It's the next level, and I think what we're trying to achieve is almost auto. If I say auto triggered, right? There's something monitoring, some kind of watchdog monitoring for a condition to change or a value to either hit within a tolerance or out of tolerance, and that actually initiates some kind of automated workflow that say, hey, look, your machine's running slow. All right, let's kick it off. Let's perform the analysis. Let's pull in all the built-in test information. Let's pull up the performance data from this time period and automatically perform the analysis, so we can give that operator, that person monitoring the setup, the system, information, and either and then go all the way to recommending. It's like based on here's the analysis, here's the data supports it. We the system recommends you take this action. Do you concur? Right. So that's all the way up to. Even maybe small ones, maybe the operator is just alerted when a change is made, right? Maybe as you go forward and train, collect more data and how you want this system to react, interact, exchange information, you reach a level to where the operator, the human in the loop, becomes almost just on the loop, right? Instead of in the loop, more of a monitoring situation.
Ian, just to add on to what John is saying, I think about decision making, and I actually think about bringing and delivering a system quicker and sooner, right? So I like to look at the digital engineering environment somewhat similar to Microsoft Office, right? Before Office 365 was set up, we were operating in Word. We were sending emails back and forth to one another to download and understand our content. Now that's more in a cohesive manner, right? We're essentially operating from the cloud. Everyone's integrated in together. We can work collaboratively on the same document or the same model. So for me, I think about producing a system quicker, and I think about getting to decision making a lot quicker as well.
Great point.
Yeah, I'll just quickly add that I feel like to me, the big importance here is developing the digital twin versus the aircraft. But I think the misunderstanding is that the digital twin shows up later in the development process. It's not true. You start developing the twin immediately. That's the first thing you do, is make this twin. There is no real aircraft until much later down the line. But you can simulate in the twin everything, all the way through sustainment and testing eval right there in the twin. Then, through using this environment, this digital engineering environment, then when the real aircraft shows up, you can pair them up and see where our twin deviates. Our twins will get better and better and better over the years as we keep doing them. But the first few the airplane's going to be doing this, we're not going to be doing the same thing. You link them up, they're also not going to be doing the same thing in sustainment, all this other stuff. So you got to practice everything, the whole life cycle in this digital environment up front, bring in the aircraft later, make sure they both match up, and then you can really start having some fun, hopefully reducing this whole life cycle time frame.
Yeah,
Definitely.
I'm glad you mentioned digital twins. Can you give a brief explanation of what that term means? I realize it's probably something to do with like a simulation in a digital environment. Is there more to it than that?
Well, I of just, to me, it's simulating the entire thing, not just the 6DOF simulation of the aircraft flying, but the sustainment capabilities of the aircraft, how you would sustain it, all the way down to engine performance and details of engine performance. So your twin can get higher and higher fidelity as you go along. But there's also a term called digital shadow, which I learned a couple years ago, which is essentially a twin that doesn't receive any information from the aircraft. So that's another side. That's kind of what you're doing up front. You're really building this little shadow up front. Then you build a twin to match the airplane because it gets feedback from the aircraft. It also provides information to the aircraft. So they're both synced up and they're both flying, hopefully doing the same thing when you're testing.
Right.
But the twin is really not just an airplane model, but the whole thing. The entire system of systems model eventually is a twin.
Thanks for watching this episode of the Model Vision podcast. On the next episode, we'll continue this conversation about digital engineering and what exactly that is for us, for our customers, and for anybody that might be interested in the world of digital engineering. This episode is cut up into 3 sections, so be sure to watch over the next couple of weeks as we finish out this conversation. John, and Casey are all in these next few parts, and they get more in depth into what digital engineering is, what it means for you, and what it means for potential customers in the future. If you want to learn more about digital engineering, you can visit avian.com/digital engineering. That's avian.com/digital-engineering. Thank you again for watching the Model Vision podcast. I'll see you guys next time.